Alright, so this one we're going to do partial fractions. Have a look. So breaking up the denominator into x and x squared plus 4. We've got an x squared on top, so we don't need to worry about any constants. And I've expanded it out so it's easier to see when we sub things in. So for example, if we sub, so we can do the cover up to find a and then sub in 0. So we would get, or we can just look at it left and right, subbing in 0 from the expansion. So you can see here you go, oh, I've got -8 and I'm going to get 4 a's. So a would have to be -2. We could find the coefficient of x squared. If we do that on the left, we have 1. On the right, we're going to have a and bx times x, so we're going to have a plus b. And a is -2, so b would be 3. Let's try the coefficient of something like x. So on the left, there are no x terms. And on the right, the only place we will get x is c times x, so 0. So c is 0. Alright, so let's look at the integral now. So this integral is now a on x, so we've got -2 dx on x, and b, c is 0, so it's b x on x squared plus 4 dx. Now we can see for that one we're going to need a 2 there, so let's put a 2 there as well. So we're going to get a -2 log x and a 3 on 2 log x squared plus 4. That's got to be positive, so we can just go like that. Now, was this? Yes, this was a definite integral between 4 and 6. So I'll do that here as well. It's between 4 and 6. So we're going to get -2. We've got a log 6 minus a log 4. And we've got a 3 on 2 log 3640 minus log 1620. Alright, so right there we have -2 log 3 on 2, or you could say log 3. So 6 on 4 is 3 on 2, or we could break that out and go log 3 minus log 2 as well. We can do that as well. And here we've got 3 on 2, log 40 on 20 is log 2. So -2 log 3. We've got a plus 2 log 2 and a plus 3 on 2 log 2. Now it is a show that, and we want 3 on 2 log 2. So we want this last term here. Let's put the other part together. So if we think about it, they want a minus. They want us to put this 3 on 2 log 2 first. Minus. So if I put the minus outside of a bracket, that would be minus there. So we can see there that they've both got 2 in them, and then we would have log, and the -1 is on the bottom, so the 2 is on the bottom, so it'd be 3 on 2. And that matches the show that. Alright, so let's move on to B. And so I've written it out for us, as well as the expansion, just to make it easier. So, for example, if we let x equal 4, on this left-hand side, we're going to have 4, 4, 16 plus 1 is 17. And x equals 4 gets rid of the b's and c's, and all we've got left is the a part. So we've got 4, 4, 16, we've got 17a, so a we know is 1. What about x equals 0? So if we put x equals 0 in, we just get a 1 on the left-hand side, and on the right-hand side we're going to get the a. Subbing in 0, aren't we? Yeah, sorry. We've got the a plus the 4c. And we know a is 1, so C's got to be 0. So we want to find B. So for example, the coefficient of x squared, 0 x squareds are on the left, and we're going to get this ax squared on the right, and we're also going to get negative b x squared there. We know a is 1, so b must also be 1. 1 minus 1 is 0. Alright, so putting that in our integral now, we've got a on 4 minus x. A is 1, so we've got 4 minus x there, and we've got our b is also 1, so we're just, and a c 0, so we've got that one there as well. Now we want to play with those a little bit. We know we want a 2 here for a derivative of the bottom, so we need a half here. We know the derivative of the bottom here is a negative, so I need a negative here. I'll put a negative 1 there. Alright, so that should work nicely. We've got now minus log of 4 minus x plus a half log of x squared plus 1 there. And is it a definite integral? Yes, we're supposed to be going between 0 and 2, and 0 and 2. Alright, so minus, if I put a 2 in, I get log 2, minus, if I put a 0 in, I get log 4, half, log, if I put a 2 in, I get 5, if I put a 0 in, I get log 1, we know that's 0, so I'll just leave it like that. Alright, so we know this is a show that, and it wants us to put all the logs together, so if we do that, let's just do this first. That's 2, this is a plus log 4, this would be, if I made it just log there, if we're root 5, if we do them all together, we've really got here a 4 and a root 5 and a divided by 2, which we know is log 2 root 5. And we've got the power, we want the power of a half, because you can see we want a half out the front. So that means we want to square everything inside here. Oops. If you square 2, you get 4. If you square root 5, you get 5. So we're going to have a half log 20 as our solution.